To create a sprite-driven point-and-click movement system in Unreal Engine, import your sprite sheets by dragging and dropping them into your content drawer. Right-click on the sprite sheet and under Sprite Actions, select Extract Sprites. Set the sprite extract mode to grid and define the size of each sprite under the cell width and cell height, then hit Extract. To create animations, simply highlight a group of images and right-click, then select Create Flipbook. Inside your character blueprint, add a component called Paper Flipbook and set the source flipbook to one of your idle animations. In this example, we are using the top-down template, which uses the character movement script in conjunction with the NavMesh bounds volume. Because this is a 2D based character, we'll need to disable Orient Rotation to Movement setting inside the character movement script to prevent the capsule from rotating, which would also rotate our flipbook away from the camera. We'll be creating a 4-way movement system, including up, down, and left, right. In the event begin play, get a reference to the paper flipbook and pull off the get flipbook function, then promote the return value to a variable that we can call animation state. Next, in event tick, pull into a branch node. We can check if our character is idle by using the capsule component's velocity and checking if the X and the Y value are equal to 0. Off the true pin, we can pull into another branch check and verify if the current animation state is equal to running left or running right. If true, then pull into the set flipbook function and use the select node and check if the animation state is equal to running right. If true, then set equal to idle right. If false, then set equal to idle left. Off the false pin, we can pull into the set flipbook function again and use the select node, but this time, we'll check if the animation state is equal to running up. If it's true, then set it equal to idle up. If it's false, then set it equal to idle down. Going back to the first branch check, we can pull off the false pin into another branch node, but this time check if the absolute value of X is greater than the absolute value of Y. Off the true pin, we can pull into the set flipbook function and use the select node again, use the capsule component's velocity and check if the X value is greater than 0. If true, then set the animation to running right. If false, then set it to running left. Then set the animation state variable using the getFlipbook function so we can accurately track the current animation state. Finally, off the false pin of the latest branch check, we can pull into the set flipbook and then into the select node. This time, check the capsule component's Y value is greater than 0. If true, then set the animation to running down. If false, then set it to running up. And don't forget to set the animation state variable to the current flipbook. And just like that, you have a sprite-driven 2D animation system in a 3D world.